Hi, and welcome to Seimpi Education. In this video, we will be exploring simultaneous equations. So, what are simultaneous equations? In some problems, you will come across two items of unknown quantity. However, even though the exact number of both items is unknown, you will know something relating to both items. For example, A and B can be unknown quantities, but you will know that both of them add up to a known number, for example, 400. X and Y are unknown quantities, but we may know that X minus Y is 20. Items M and N are unknown, but we know that both of them add up to 68. Essentially, we can find a relationship between two unknown factors and express it as a mathematical equation. But how do we go on from there? Since we have two unknown factors, it is impossible to find out the exact values of the unknowns unless we have more information. Therefore, we need to find a second relationship between the two unknowns and form a second equation. Using these two equations, we can then manipulate them and use the second equation to eliminate one unknown factor from the first equation, thereby solving for the other unknown. Let's take a look at an example. In a school, there are a total of 400 students. 2 out of 5 of the upper primary students are in arts-related CCAs, while 2 out of 3 of the lower primary students are in sports-related CCAs. There are 100 more students in sports-related CCAs than arts-related CCAs. How many upper primary students are there in this school? So, how do we know that this question involves simultaneous equations? For one, we can identify that there are two unknown factors, the number of upper primary students and the number of lower primary students. Furthermore, we can identify a relationship between these two unknowns. Both upper and lower primary students add up to a total of 400 students, and that there are 100 more students in sports-related CCAs than arts-related CCAs. We can use two different methods to tackle this question. One way is to use the model method. Since there are a total of 5 units of upper primary students and a total of 3 units of lower primary students, we can draw a model representing the total number of students in the school as such. This will be our first relationship. However, remember that we need more information before we can solve a problem with two unknowns. The total number of students in sports-related CCAs is 3 units of upper primary students plus 2 units of lower primary students. The total number of students in arts-related CCAs is 2 units of upper primary students and 1 unit of lower primary students. Thus, by simplifying this relationship, we can see that 1 unit of upper primary students plus 1 unit of lower primary students equals 100 students. This is our second relationship. So we finally have two relationships that we can use. So how do we eliminate one unknown factor here? Notice that we can substitute our second model into our first model, each time taking 100 off the total of 400. At the end of this, we are only left with 2 units of upper primary students that make a total of 100. Thus, the problem has been greatly simplified and we can easily find out the total number of upper primary students. The second method to solve this problem is using algebra. We can turn the models that we drew in the first method into algebraic equations like so. These are the relationships that we found in the first part. However, we just expressed them using algebraic notation instead. Since we want to eliminate one unknown factor, we can take the second equation, multiply it throughout by 5, and then substitute it back into the first equation. Simplifying this eliminates the unknown u and leaves us with the expression 2L equals 100. From then on, we can easily solve for 1L and then substitute that back into equation 2 to find the value of 1U. To summarize, when we encounter a problem involving simultaneous equations, we need to first identify the relationships between the unknowns, and then we express those relationships either using a model method or an algebra method, and then we try to eliminate the other unknowns.